Very good morning, friends. We have dealt with the various methods of preparation of alkanes. Today, let us discuss about the types of reaction that an alkane can undergo. Alkanes, as such, they are highly unreactive species. Why is it so? It's because of the fact that the carbon and hydrogen present in the alkane are having equal electron sharing between them. The electron sharing between carbon and hydrogen, though they are different atoms, they are equally shared because of the fact that carbon and hydrogen are having equal electronegativities. That's why carbon is satisfied with hydrogen and hydrogen is satisfied with carbon. When you are completely satisfied, what happens? You become lethargic. Yes, we have achieved everything. If we feel the next step of achievement will get stopped. That is the condition of the carbon and hydrogen and carbon in alkene. That's why they won't react at all. Most rugged species we call it as. Now, but still we should make them react. What we should do? It is something like we have to forcefully make it react. If you want to forcefully make it to react, we have to apply stringent reaction conditions. What are the stringent reaction conditions? Like very high temperature, very high pressure. When I give supply, it do not have alternative. That's why it starts reacting. Right. Only few reaction occurs, that also forcefully. The one of the reactions that alkanes can undergo is halogenation of alkane or halogenation of methane. I can take it as an example. Alkanes can undergo halogenation. If I take methane CH4 and make it to react with chlorine, I have to use either UV radiations or I have to use temperature 520 to 670 degrees centigrade. Then I'll get one of the hydrogen in methane is replaced with chlorine to give chloromethane, and in the methyl chloride the hydrogen is replaced with chlorine to give dichloromethane, and in the dichloromethane one of the hydrogen is replaced by another chlorine atom to give rise to trichloromethane, and in trichloromethane the hydrogen present in it is replaced by chlorine to give rise to carbon tetrachloride. Four products are formed in a single reaction. Single shot, four products. The reaction continues until all the hydrogens in the methane is replaced by chlorine. I'll get the mixture of chloromethane, dichloromethane, trichloromethane and tetrachloromethane. The reaction is very difficult to occur. We have to use either UV radiation or very high temperature of 520 to 670 degrees centigrade. But once it starts, it gives four products at a start. Right. What is the mechanism which it follows to give this product? Let us look into it. It has been confirmed today that it undergo free radical substitution. The chlorine radical is formed, and this chlorine radical substitute the hydrogen in the methane to give rise to chloromethane, and from this chloromethane hydrogen is substituted to give other products. The free radical is the intermediate species formed in the course of the reaction. The mechanism followed is free radical substitution. The intermediate formed is free radical. It occurs in three steps. First step involves the initiation of the chain reaction. The second step is the propagation of the reaction which is initiated in the first step. After completion of all the starting material what we use, it undergo termination. It undergoes reaction in three steps: initiation, propagation, and termination. How it can be initiated? Let us look into it. We can continue this. First step is the chain initiation. When you irradiate the methane and chlorine, the chlorine undergoes reaction to give rise to chlorine free radicals. It undergoes homolytic cleavage. The chlorine molecule, it dissociates into two chlorine radicals. The bond between the chlorine molecule is formed by sharing of one electron each. This chlorine atom gives one electron. This chlorine atom gives another electron. When it gets dissociated, this chlorine takes its electron and this chlorine takes its electron, and it gives rise to chlorine free radical. मैं मेरा क्लोरीन लेके जाता हूं, तू तेरा इलेक्ट्रॉन लेके जाओ. Then equally it is sharing. When the dissociation of the bond occurs by equal sharing of electron, it is called as homolytic cleavage. When there is a breakage of bond, it requires energy. The heat of hydrogenation of this reaction is found to be plus 243 kilojoules per mole. It is an endothermic reaction. That's why it requires external energy to be supplied for the reaction to occur. Here I use higher temperature or I use UV radiation to undergo homolytic cleavage to give rise to free radicals. Formation of free radicals is the initiation for the reaction. The dissociation energy for chlorine molecule is 243 kilojoules per mole for homolytic cleavage to occur. That's why we have to supply energy. After this chlorine radical which is formed, this is having one electron less than the requirement. That's why it is highly reactive species. It has to become stable, means it has to gain that electron. As it is highly unstable, it becomes highly reactive. It is something like, if I am in need of something, I will work more. Means this also reacts more. Right. The chlorine radical which is formed reacts with methane. This requires one electron for satisfaction of octet. That's why it abstracts one hydrogen radical from the methane to form HCl. The carbon hydrogen bond breaks and the hydrogen takes its electron, leaving one electron onto the carbon, and when the one electron is left, the methyl radical is formed. The hydrogen radical combines with chlorine radical to give rise to HCl. Chlorine radical reacts with methane to give methyl radical. The methyl radical which is formed is also unstable because it is in need of one electron for octet formation to be in stable state. The energy required for this is plus 4 kilojoules per mole. Heat of hydrogenation is found to be 4 kilojoules per mole. It is also endothermic reaction like that of the dissociation of chlorine molecule, but it requires less energy. The methyl radical which is formed is also unstable as it is in need of one electron. That's why it is also highly reactive species. The methyl radical which is formed react with chlorine to give methyl chloride and chlorine radical. Is to abstract the chlorine atom in the form of radical from the chlorine, giving rise to chlorine radical. The energy delta H, heat of hydrogenation of this, is minus 113 kilojoules per mole. It is an exothermic reaction. It itself liberates energy. Totally, the difference between the delta H of chlorine radical formation and methyl radical formation, 1 minus 113 minus 4 is minus 109 kilojoules per mole. It is an exothermic reaction. It itself releases energy. The chlorine radical which is formed is unstable and highly reactive. That's why that reacts with methane to give methyl radical, and methyl radical which is formed react with chlorine to give chlorine radical, and this continues until all the methane gets completed. It propagates the reaction by chlorine radical reacting with methane and methyl radical reacting with chlorine. That's why it is named as chain propagation. It propagates the reaction. Chlorine radical abstract hydrogen radical from methane to give rise to methyl radical. Methyl radical reacts with the chlorine molecule to give rise to chlorine radical and methyl radical, and the process continues as all the methane gets completed. We may ask one question: why the chlorine radical reacts with methane to give methyl radical only and gives rise to HCl? It can also react in this fashion. The chlorine radical can combine with methyl radical, and it can give rise to methyl chloride or chloromethane and gives rise to hydrogen radical. However, the methyl radical is only formed, not the hydrogen radical. How can it be explained? The formation of methyl radical and the bond dissociation of methane into hydrogen and methyl radical, if I calculate the heat of hydrogenation, it is found to be 75 kilojoules per mole. It is an endothermic reaction. Excess energy has to be supplied. Whereas when it forms methyl radical, it is an exothermic reaction, as we have seen in the previous slide. It is reaction is more easy and it forms more easily. Formation of methyl radical is more easier than formation of hydrogen radical. Hence, here in this we have to supply energy. There energy is liberated. More easier the formation of the intermediate, more it is formed. That's why this formation of methyl chloride and hydrogen radical is not occurring. It is the methyl radical which is formed. By studying of the energetics of the reactions and each and every step, we can conclude that it is the methyl radical which is formed as an intermediate. Once all the methane gets completed, chain termination occurs. The chlorine radical reacts with chlorine radical to give rise to chlorine molecule. The reaction gets terminated. If all the chlorine gets completed, chlorine radicals, then two methyl radicals they combine together to give ethane. Along with chloromethane, dichloromethane, trichloromethane, and tetrachloromethane formed, it gives rise to ethane as another byproduct. This is the as the free radicals are formed in the reaction process as intermediates, it is called as free radical substitution. The methane hydrogen is substituted by halogen radical. It follows free radical intermediate formation, and that's why it is said that it follows free radical substitution mechanism. The hydrogen is replaced by chlorine free radical or halogen free radical in general. This is how the reaction occurs by following the free radical substitution mechanism in the halogenation of methane. Let us continue with other types of reaction the alkanes can undergo in the next presentation. Till then, have a nice day.